Here are your homework solutions on inverses of logs and exponentials. A log and an exponential both have inverses. They're 1 to 1. They only increase. There's no turning points. And we have to think, how do I find the inverse of these equations? So if you need support, watch along, but best is if you try it first and then watch the video and see how you did. And hopefully my camera can focus in most of the time. So first we're going to inverse the equation. So x equals 6 to the y. And then we need to solve for y. So we learned that exponentials and logarithms are inverses of each other. So to solve for y, we're going to write it as a logarithm. Put space here. So we're going to write y equals the base is 6 of x, and that's it. That is the inverse of what you see. Let's try that again. We're going to inverse this. X equals 2 to the exponent y plus 3. We're going to write it as a logarithm. So an exponent, we're going to write as a logarithm. The base is 2, and then inside the logarithm is x. To get y by itself, the inverse of adding 3 is to subtract 3, and then the symbol for inverse, that little negative 1. So we have log x base 2, subtract 3, and we found the inverse. Again, we have an exponential. So step number 1 is to inverse x and y. And then I need to have the algebra skills to get y by itself. So the inverse of dividing is to multiply by negative 4. The inverse of subtracting 3 is to add 3. Now the exponential is isolated. Now I can inverse the exponential. So another way to write that exponent y is as a logarithm. Now the base is e. So the logarithm with the base of e is ln, the natural logarithm. And then inside that logarithm is negative 4x plus 3 with parentheses. And again, we can use this symbol for inverse. All right, let's keep practicing. At some point, you need to press pause and try it first. You have to do the work to learn the work, not to do the work. So instead of adding 10, the inverse is to subtract 10. Now the exponential is isolated. Another way to write that exponent is as a logarithm base 4, and inside the logarithm is x minus 10. Get y by itself by adding 1, and that's the inverse, the symbol for inverse. All right, we're going to inverse this. X equals 5 to the exponent y divided by 4 plus 3. Subtract 3. Now the exponential is isolated. Write it as a logarithm. So y divided by 4, base 5 of x subtract 3. The inverse of dividing by 4 is to multiply, and you have your answer. Again, we're going to inverse this. Oh, make sure I have a y there in the exponent. All right, to solve for y, we're first going to subtract 10. Then we're going to divide by 3. Now the exponential is isolated, so now another way to write 2y is as a logarithm base 2. And inside the logarithms, x subtract 10 divided by 3. And then divide by 2, and you have your inverse. Oh, number 7. Look how easy that one is. Just simple. So x equals ln y. It's already isolated. So y is the base for ln e to the exponent x. That's the inverse. Again, inverse the equation and then solve for y. So we're going to subtract 3. Once the logarithm is isolated, then we can write it as an exponential. So what's inside the logarithm is y subtract 2. The base is 2. And then the exponent is x minus 3. Add 2 and you have the inverse. Number 9, inverse it. x equals, oh, I forgot the 3, log base 4, 2x. Now, there's no parentheses there. So 2x is inside, but subtract 1 is not. So we're going to add 1. Then I'm going to divide by 3. Now the logarithm is isolated. So if you don't see parentheses, it's not inside the logarithm. So the 2x is only inside the logarithm, not the subtract 1. To write this as an exponential, what's inside the logarithm is 2x, the base is 4, and then the exponent is x plus 1 divided by 3. Divide by 2, and you have the inverse. So 4 to the exponent x plus 1 divided by 3, all divided by 2. All right. Inverse the equation. X equals ln y subtract 4 plus 2. To solve for y, subtract 2. The inverse of a logarithm is exponential, so what's inside the logarithm? The base for ln is e, and then the exponent is x minus 2. Add 4, and you have found the inverse. All right, turn the page. Hopefully your work is done and you're checking your work by now. So again, I have a logarithm. So step 1, I'm going to create some space here to answer it. So step 1 is to inverse this. So x equals log base 2 of 2x y subtract 1 plus 4. So I'm going to subtract 4 to begin with. Move that over here. Now the logarithm is isolated. What's inside the logarithm is 2x subtract 1. The base is 2, and the exponent is x minus 4. Get going. To get, I got too many x's here. Which one is what? This one is a y. This one is a y. All right. To get y by itself, I'm going to add 1. And then I'm going to divide by 2. So that's the inverse. 2 to the exponent x minus 4 plus 1, all divided by 2. All right, number 12, we're going to inverse this. X equals. And then I'm going to solve for y. So I'm going to subtract 1. I'm going to divide by 4. Then I can write it as an exponential. So I have x subtract 1 divided by 4. Now the logarithm is isolated, so now I can do the inverse, which is to write it as an exponential. That's 3y subtract 2. The base is 3. The exponent is x subtract 1 over 4. Then we're going to add 1, or add 2, and then divide by 3. And you have the inverse. All right, number 13. Just a few left here. So, again, you did this already. So let's see if you did it right. So inverse x and y, divide by 3, and then write it as a logarithm this time. So the exponent is 3y. The logarithm has a base of 2, and then x divided by 3. And then the last step to get y by itself is to divide by 3. Number 14. All right, let's inverse this. X equals. The exponential is already isolated, so we're going to write that exponent, so 1 divided by y plus 2, as a logarithm. So base 3 of x, we're going to subtract 2. Now, to solve for y, we're going to do this in 2 steps. So the inverse of dividing is to multiply by y. So we're going to multiply both sides by y. And then we're going to divide by what's inside the parentheses. And that's the inverse. So we multiplied by y, and then we divided instead of multiplied to get the inverse by itself. All right, 2 more left. So we're going to inverse this. X equals. Now know that this is inside the logarithm. This is not inside the logarithm. and then I want to solve for y. So the inverse of subtracting 2 is to add 2. The inverse of multiplying times 2 is to divide by 2. Now the logarithm is isolated. So what's inside the logarithm is y divided by 2. The base is 5, and the exponent is x plus 2 divided by 2. Then the last step to get the y by itself, the inverse of dividing by 2 is to multiply, and you have the answer. All right, last one. You guys are doing great. And then we're done. So let's see if you did it right. Inverse this. X equals 3 log base 6, 2 over y, subtract 1. Step 1 is to divide by 3. Now the logarithm is isolated. So now the inverse of a logarithm is an exponential. So what's inside the parentheses? The base is 6 and the exponent is x divided by 3. Then we're going to add 1. We're going to multiply times y. And then we're going to divide by this, both sides, and then there's your answer. That is your inverse. So it's 2 over 6 to the exponent x over 3 plus 1. That's it. Good luck on the quiz. Good job getting your homework done. Mr. G Math.